Okay, well, it's 5 o'clock my time, so let's make a start. We've got quite a lot to get through today in this course. So good morning to those of you on the West Coast. Good afternoon to those of you joining us from the East Coast. Good evening to anyone joining us from Europe or stations further east, such as South Africa. And a very warm welcome to you all. Thank you for joining this, the 14th of our regular series of short courses on pumping topics. This one's going to last about 45 minutes, allowing us a little bit of time at the end for a Q&A session after the presentation. We are into session 14 now, and I expect that most of you will have attended one or more of the previous sessions. So I'm going to forego the usual 7 or 8 slides, which remind you of who we are and what we do, and I'll move straight on to the topic at hand. I've moved those slides to the very end of the presentation, and they will be in the PDF copy that you receive, so you can peruse them at your leisure. So let me just restart this. And here we go. Here is a listing of the previous short courses we've run during the last year. If you've missed any of them, you can get a copy of the materials from our website. Use the following link. Go to rawpumping.com and follow the link to the RP short courses. If you go to rawpumping.com, you'll get to this screen, and you see here at the top, RP short courses. If you click on this, it will take you to here, and you can go to the courses that it lists them all there, and you can click on any of them to see the course material. You can get to this one either from rawpumping.com and clicking on the short courses, or directly from this link here. And you can also join us in YouTube. Well, in part 1 of this course, 3 weeks ago, we looked at performance testing in general, including NPSH testing. In this one, we're going to look at the various inspections and tests that are frequently specified on the data sheets. I'm indebted to Jennifer Knox, the Global Product Manager for BB4 and BB5 pumps at Raw Pumping, for the vast majority of this material. We're holding a Q&A session at the end, so please use the Q&A facility at the bottom of your screen to ask any questions. Please use the Q&A rather than the chat facility. It's much easier for me to be able to police it. I'll address those that I can live at the end of the session, and the rest will address by mail in the coming days. We are recording this session, and we'll make it available to all attendees as a YouTube link, as well as by emailing you a PDF version of the slideshow and of the Q&A summary from both of today's sessions. So here's an overview of what we're covering today. If you look at the API 610 datasheet, there are numerous cells where you select various options, the green cells, for various inspections and tests. We're going to look at, discuss, and explain most of these inspections and options. So we start with shop inspection. Shop inspection, which cross-references really observed tests and witnessed tests. With both witnessed and observed tests and inspections, we have to schedule the test and give 5 days notice to the client. With an observed test, if the customer inspector doesn't show, we can carry on. But with a witness test, it's a hold point, and we cannot proceed without the inspector. We'll find that vendors charge the same for an observed or witnessed. To us, there is no difference. In both cases, we have to carry out a pre-test, we have to give 5 days notice, and we have to carry it out during normal working hours. We cannot slot it in at a few hours notice on second shift or on a weekend, as we might do if it were a non-witness test. Testing with a substitute seal. This is seldom requested. We would nearly always want to use the contract seal. The only time we might want to use the a shop seal might be if it were capable of being damaged by running in water, or if the seal was late. Material certificates or material test reports, MTR. 3 types. There's the type 2.2, the 3.1, and the 3.2. The 3.1 is often called an actual MTR. The test report is traceable back to the actual heat number inscribed on the casting or forging or plate or bar stock. It's required by API 610 for pressure containing parts, so the case and cover castings, barrels for a BB5 pump, nozzle head and suction can fabrications for a VS6. It's also required for impellers and shafts. Now this is perfectly usual and readily available. The 2.2 is often called a typical MTR, and it's used for small parts, pipe fittings, bolting, wearings, bushings, stock components, components that we source from stockists, where the actual heat number is not inscribed on the part. There will be a 3.1 somewhere in the system, but nothing that positively traces that particular component to that particular heat and MTR. If you require a 3.1 for these components, it will usually be achieved by destructive testing of a component at an independent laboratory, or by specifically ordering for that particular contract, and that would be expensive. Now 3.2 means the material testing, the chemical and physical tests that are carried out to prepare a 3.1 are witnessed by the customer's inspector. Sounds straightforward enough, doesn't it? But no, it's not. Foundries are a continuous 24-hour operation, or 16 hours at least. The test coupon is poured at the same time as the parent casting and is immediately tested in the foundry lab. Well, that might be in the middle of the night or at a weekend. Commercial foundries will pour the castings as and when they have a batch of material ready to pour. They'll not generally be able to give 5 days notice and tie it down to a particular day or time. Now, some high-end foundries, for which you can read expensive foundries, have third-party resident or regularly available inspectors and will be able to accommodate this, but at a price. Most pump manufacturers do not have their own foundries anymore, and they use commercial foundries. Rotor is one of those few that does have its own foundry, so we are better able to accommodate a request for 3.2s. But the most efficient way to obtain a 3.2 for commercial foundries is to get additional coupons or materials poured at the same time as the parent castings and have them tested at an independent laboratory where it can be scheduled and witnessed by the customer inspector. Fabricated pumps, VS6 pumps, are made from plate and pipe and flanges that are supplied by stockists rather than directly from a forge. So again, additional materials need to be tested at an independent laboratory. You can get a 3.1, no problem, but a 3.2, you would need to get it independently tested. Now, all of this costs time and money. So don't just think, that would be nice to have, and tick the box. Ask yourself before specifying if it is really necessary. Is it critical service, very high temperature, very high pressure? Is it worth the cost and lead time? Because it could easily add a month to the delivery time. Still on material certificates, here is an example of a 3.1 certificate. We have the heat number, we have the elemental analysis, we have the mechanical properties, we have the heat treatment. In all cases, the inspector will have the ASTM or the DIN for the material in front of him, and he will check that every reading is within spec. Then he stamps it and signs it. Casting weld repair procedure. This is usually required for any casting repair carried out after the casting leaves the foundry. Welding at the foundry is called production welding and is a normal procedure. It's documented at the foundry, but it's not a weld repair. After the final casting heat treatment, any further welding from that point is a weld repair. Maybe you're machining the casting and you uncover a fault. Well, then that's a weld repair and is fully documented by the pump manufacturer. To save on time, the weld procedures are agreed in principle in advance, and a particular weld repair with its associated weld map is submitted for approval as and when required. Inspection of case connection welds. Case connection welds means vents, drains, and seal piping connections. The actual penetration of the pipe into the case casting is most commonly in the industry a socket welded connection. Imagine this is the case rather than a flange. So with this type of connection, the pipe is pushed all the way into the machine socket, then it's pulled back slightly, and then a fillet weld applied to make the connection. Now, LPE or MPE will find discontinuities in the weld surface that may indicate a defect. RXE of a fillet weld will not give any meaningful results. What it will reveal is if this gap at the bottom of the socket is there as it should be. A full penetration weld, like this, is generally not used, but an engineered butt weld is sometimes possible, but again, not really accessible to RXE. Rotor pumping uses an integrally flanged design on most pumps, so no case connection weld in these instances. So here on a small pump, it's an engineered flange at this point on the drain, and on larger pumps, it's a conventional ANSI flange. The piping itself can be either socket welded or butt welded, and if it's butt welded, it can be accessible for RXE. Casting inspections. Well, I covered this in more detail in session 10 of these short courses on non-destructive examination, so you may want to revisit that course. Here and in the next few slides, you can consider it to be a quick refresher. I'm not going to go through it in detail as I did in session 10. The four types of NDE in increasing order of price are LPE, dipenetrant, MPE, mag particle, UTE, ultrasonic, and RXE, X-ray. LPE will indicate surface breaking cracks and flaws that will then be excavated to find the full extent, and then they'll be weld repaired. Similarly, MPE, magnetic particle examination, indicates surface breaking cracks and flaws, but also flaws that are near the surface but don't actually break the surface. It only works on ferromagnetic materials, so not on stainless steels or duplexes. UTE will detect flaws deep in the material. The ultrasound will bounce off a crack or flaw and will show on the analyzer. So here you see it bouncing off a crack. and again off the rear surface of the part. If you can easily get to both sides of the part, such as on a plate, you can use the more accurate attenuation technique, which uses a separate transmitter and receiver. So here you'd move the transmitter and the receiver down the plate until you saw the floor indicated here. And the second peak is the bounce off the back sample. RXE is the most expensive. It detects below surface cracks and defects, but it takes a lot of skill and training. Pump suppliers will seldom have this expertise in-house. They'll usually bring in a specialist contractor or send the part to be examined to a laboratory. And for the main castings, it will be done at that foundry, which will be a high-end foundry, an expensive foundry. A couple of examples: casting porosity. Yeah, shrinkage and tears. Again, more on this in session 10. But what does API 610 require? Let's help you to fill in your checklist and the data sheets. Here is table 14 from API 610. You'll see 3 classes of inspection: 1, 2, and 3. 1 is the minimum, 3 is the highest level. And it depends on the temperature and pressure. Class 2 inspection kicks in at 80% of max allowable working pressure and 200 degrees centigrade, 390 Fahrenheit. Now, most process pumps with 300-pound flanges have a max allowable working pressure of 40 bar or 580 psi. So 80% of this value is 32 bar, 465 psi. So if the calculated required max allowable working pressure, and remember that it's shut-off head plus 10%, plus the maximum suction pressure and maximum specific gravity. I'll say that again: shut-off head plus 10%, plus max suction pressure and at max specific gravity. If that is at or above 32 bar, then class 2 inspection is required. So what does it require? On the casing, it requires visual inspection plus mag particle or liquid penetrant of critical areas. Critical areas. These are defined in the footnotes to the table. So critical areas are inlet nozzle locations, outlet nozzle locations, casing wall thickness changes. And the manufacturer shall submit details of the critical areas to receive inspection for the purchaser's approval. Now, depending on who you talk to and the complexity of the casting, this could be interpreted as 100% of the casting. On a simple OH2 or BB2 casting, some consider it to be just where the casting risers occur. Going back to this slide, we see wrought is much the same: visual plus magnetic particle and LPE. The nozzle welds, so on a VR6 pump, 100% MPE or LPE. Auxiliary connection welds, mag particle and LPE. Internals visual. The auxiliary process piping, that's your vents and your drains, LPE. And if it's a butt welded auxiliary piping, a bit of radiography in there as well. Now, if we go up to level 3, we see that applies when you have a specific gravity less than 0.5 or temperatures above 200 degrees centigrade and the SG is less than 0.7 or at greater than 260 degrees centigrade. And now what we're doing is we're bringing in radiography or ultrasound in all these areas. Let me just reiterate here, it's not just a cost issue having radiography or level 3 inspection. If you specify radiographic inspection of castings, then you restrict the choice of foundries to those that have in-house RXE inspection facilities. And these are the most expensive foundries with the longest lead times. So only specify it when you really need to and are prepared for the cost and lead time implications. This is table 15 from API 610, which references the standards to which the NDE should be carried out and the acceptance criteria. So it's the ASME Boiler and Pressure Vessel Code, the BPVC, section 5 for methods, and section 8 for acceptance criteria. This will tell you when a floor is allowable or not, normally how big, how near the surface, etc. Moving on, hardness testing. I've most commonly seen this specified for when you're pumping H2S, so H2S service and after weld repairs, after post-weld heat treatment, to check that the post-weld heat treatment has been correctly done. But it could also be used to check wearing hardness difference between impeller and case wearings. Remember, there's supposed to be a 50 Brinell hardness number difference between the impeller wearing and the case wearing. This is normally achieved by using different grades of material, such as 410 against 420 stainless. Sometimes it's done by stelliting one of the wearings. Positive material identification. Well, this is sometimes specified as a double check on the MTR. So it could be an alternative to getting a 3.2. In fact, you get a 3.1 and then do some PMI on it when it arrives. But its most useful use is to check bulk items such as piping or bolting. 304 and 316 piping might be stored next to each other in the stores, and it's possible that a piece of the wrong grade might be picked up by mistake. Also, it's a check that the correct filler rod has been or is being used in welding. It's usually carried out with a handheld gun, X-ray fluorescence type, which gives a digital readout of each of the alloying elements. Results can be uploaded to a computer for record purposes. Note that it's not suitable for carbon steel or cast iron, and it doesn't read carbon content. Next, impeller and rotor balancing. ISO 1940 grade 2.5 is API standard, and there's an option for grade G1. Now, this is one of those things that API 610 got wrong. It's frequently specified as people assume that it must be better. But not only are the results unrepeatable, which means if you balance the part, take it off the arbor, put it back on again and check, it will give a different reading. So not only is it unrepeatable, but per the reference standard, ISO 21940, it's inappropriate. Here's an extract from 21940. You can immediately see that grades 6.3 and 2.5 are appropriate for pumps and other similar equipment. Grade G.1 is appropriate for audio and video drives and grinding machine drives. Go figure. Complete rotor balancing is standard on multi-stage pumps or on high-speed pumps. It's not really possible on an OH2 pump because during balance, the shaft needs to be supported either side of the impeller in the middle. And that's not how an OH2 pump works, because it's designed to be run supported from one side as an overhung load. So don't specify it for an OH2 pump. Now, the complete rotors of VS6 pumps cannot be balanced either. VS6 pumps have long, skinny shafts, which are designed to operate in the vertical plane. Balance machines will only take a rotor mounted horizontally and supported at either end. VS6 rotors are assembled stage by stage within the diffusers or bowls, which have a bushing at each stage, one here and one here. An assembled rotor without these diffusers and these bushings and mounted horizontally, supported at either end, will look like a banana and will not be anything like representative of the assembled pump. So don't specify rotor balancing for a VS6 pump. Same applies to a VS4 pump as well. Finally, residual unbalance test. Not really necessary. The balance report that you get for any dynamic balancing that's been done, it includes the residual unbalance on that form, on that record. So the residual unbalance test would just be a double check of the original balance test. Notification of successful shop test. Hardly necessary, really. It references 8.1.1c and 8.3.3.5. I mean, it's no problem. It would be usual, of course, before calling the customer in for a witness test. Base plate test and nozzle load test. These are listed separately on the API datasheet, but they are effectively the same test. They're seldom, if ever, specified. I don't think I have ever seen it specified in all my 40 years. We can do it, and it was done on the prototype pumps when API 7th edition came out, and the nozzle loading data changed significantly from 6th edition. So at that time, we did do some prototype testing on the designs of base plates and pumps, just to check that we were going to be within those. But I don't think I've ever seen it specified on a production pump. Hydrostatic test, 1.5 times max allowable working pressure, 30 minutes. Socket welded drains and seal piping would be welded to the casing before the hydro test. If the specific gravity is less than 0.7 or the operating temperature is above 260, then we add a wetting agent to the hydro test water. This is because these hydrocarbons, light hydrocarbons, are more searching. They will find cracks more easily than would water. So we apply the wetting agent. On a VS6 pump, the pressure boundary is the can and the nozzle head. So the bowls and the column don't need to be hydro tested, but they can be if you want. And so that's an option for you. The performance test, well, we covered this in part 1 of this short course, so consider this just to be a refresher, this slide. Note here, these are 11th edition, 6 points. If you're carrying it out to 12th edition, there are 3 additional points, unless it's a very small pump, less than 11 cubic meters an hour, in which case we don't need to do 0.3 or 0.5. These 3 additional testing points are likely to have a price implication for you. It's going to take longer to test, and on smaller pumps, some of these test points are going to be on top of each other. Never mind the very tiny pumps that are below 11 cubic meters an hour, but many of the pumps, less than about 200 cubic meters an hour, a lot of these points will be on top of each other. And for many pumps, I question whether a curve drawn through 9 points is any more accurate than one drawn through 6 points. Well-regarded mathematician John Neumann is attributed to have said about curve fitting, with 4 parameters, I can fit an elephant. With 5, I can make him wiggle his trunk. Might be a useful discussion topic in the Q&A. Okay, another refresher slide. I covered these in part 1. Is the power versus flow curve. Is the head versus flow, efficiency versus flow, and NPSH versus flow. And here are the NPSH elbow curves that went to make up this one. Vibration measurements are also measured during the performance test at these points, X, Y, and Z, horizontal, vertical, and axial. And here the NPSH test. Again, I covered this in detail in part 1. We will look at NPSH first stage only, this option. This is usual for BS6 pumps. We would build it as a one-stage pump and NPSH test it. But with horizontal multi-stage pumps, it isn't possible. And API 610 does allow this. And it allows you to calculate the first stage head by dividing the total head by the total number of stages. And all vendors are going to be asking you for this dispensation. Retest on seal leakage. Yeah, we'd probably want to do this anyway. Though there can be good reasons for seal leakage. For example, a seal that is designed for very high suction pressure. And of course, we don't duplicate that very high suction pressure on the test loop. Retest after final head adjustment. Well, API 610 says that no retest is required if the sole reason for the retest is impeller trimming by less than 5% of the impeller diameter. But you have the option on multi-stage pumps to ask for this retest. Any trimming will have been done after the factory in-house test, so this scenario will seldom occur on a witness test. Complete unit test, often called a string test. Now this is usual on big, expensive, complex packages. If I was spending $1 million on a BB5 with a lube oil system, and a seal oil system, a gearbox, a VFD, a control panel, then absolutely I'd want to have a complete unit test. But if I'm spending $50,000 on an OH2 or a BB2, then I certainly wouldn't go to that considerable expense. And it might not be available in any case for this type of pump, OH2 or a BB2. Now here is a big BB5 pump undergoing a string test at the Rotor and Witten factory. It's fairly common to have tests on these big, expensive, complex packages, and the Witten factory is set up for this. I consulted a friend of mine, Mike Sorrell, who is with Sulzer Pumps, and he confirmed that their Leeds, UK factory carries out such complete unit tests on their big engineered packages as routine. They can even test with gas turbine drivers, such as a Rolls-Royce RB211 or a Solar Titan. For contrast, this is the setup for a normal performance test of a BB5 pump. Note the test pad with slots to allow quick setup and alignment of drive components, test shop pedestals, test shop gearbox on test shop pedestals, temporary seal flush piping, test shop instrumentation. This is the setup for a normal performance test of OH2 pumps. You can see 3 pumps on test here at the same time. Note the test pad with slots to allow quick setup and alignment. No base plate. Test shop pedestals. Test shop motor on test shop pedestal. Temporary seal flush piping. Test shop instrumentation. And as you can see, there will be no room to set up a complete unit test on this test loop. Actually, you can see a very small pump here on the third plinth that is being tested on its own base plate. So this is unusual, but it's possible. Now we could set up for a complete unit test of an OH2 or BB2 on the large test loop at our Tulsa factory, but it would be expensive. Remember, OH2 and BB2 test loops are set up for fast turnaround. 2 tests a day, 3 tests a day. A complete unit test will tie up a test loop for a week. Here's an extract from an internal question list that our application engineers use if asked for a complete unit test on an OH2 or BB2 pump. As you can see, it's not as straightforward as you might imagine. The electrical supply available for the contract motor. Is the motor power big enough for a full test? Is there space? And so on. If the contract seal system is required, are the utilities available? A lot of questions and things to think about. So think long and hard before you check the box for this test on a routine pump, a standard pump, an OH2 or BB2. Sound level test. Noise level readings taken during performance test are indicative only. We often do it and it's a useful reference, but they cannot be guaranteed. You've got a lot of background noise, especially from the throttling valve on the discharge of the pump. That will give a lot of noise back into the system. The test shop setup is not as strong as the ultimate one is going to be at site, and the piping is temporary as well. So you can't get a guaranteed noise reading. The readings are just going to be indicative and will help you to ascertain when you get it to site if the pump is indeed performing as expected. Cleanliness prior to final assembly. Well, this has time impact because we need to put a hold at this point while the customer inspector is called. Now, if the inspection is also called for at sub-suppliers' works, then we need to ensure that this is in the inspection and test plan for those sub-suppliers too. Check for coplanar mounting surfaces. Well, this means checking that the mounting pads are flat and parallel. And now a mechanical run test, as opposed to a complete unit test. A mechanical run test. Okay, the standard performance test will normally take half an hour. Now, most vendors will allow it to run for a further half hour without charging extra. Now, this is a mechanical run test. Most problems are found within the 30-minute performance test anyway. Extended test runs tie up the test loop, preventing other pumps from being tested. So they can be expensive. There are 3 mechanical run test options listed here. First one, until oil temperature is stable. Well, this can be anywhere from 1 to 4 hours. Or our mechanical run test after oil temperature stable, well, that means it could be up to 8 hours. And a straightforward 4-hour mechanical run test, we would carry out the performance test, say 30 minutes, then we would continue the test until the total running time is 4 hours. Unusual one, true peak velocity rather than root mean square, which is what we normally measure. It was a bulleted paragraph in the 10th edition, and it's not in the 11th or 12th at all, but it's still in the data sheet. Bearing resonance test. often called a bong test. It's to determine the natural frequency of the pump to be sure it doesn't fall near its operating speed. So you attach a probe to the bearing housing, attach a vibration analyzer, and then hit it with a rubber hammer and analyze the results. It's done on the bearing housing with the pump unpiped. Similar but different is the structural resonance test, which is done on a vertical pump. It's say a VS6 pump, if it's an unusual design or a pump size that has not been well supported in the vendor's installation list. I'll give you an example from my own experience. I had a VS6 pump once operating at 3600 RPM, but with a separate thrust bearing in the pump rather than in the motor. Now this pump model had dozens of references at 3000 RPM with a separate thrust bearing, and it had dozens of references at 3600 RPM without a thrust bearing, in other words, thrust in the motor. But it had never been built at 3600 RPM, 2-pole 60 Hertz, with a thrust bearing before. The bong test indicated a resonant frequency problem, and the nozzle head was modified. Remove and inspect hydrodynamic bearings after test. Yep, this is straightforward. Here is one to watch, auxiliary equipment test. It will be usual to have agreed ITPs for each of the auxiliary equipment, and these would normally be fully tested at the sub-vendor. Now, if there's a complete unit test, you might want to duplicate some or all of that testing, and it's important to clarify that. Impact testing is most commonly specified in low temperature service, when some steels can become brittle. The material specification, the ASTM or the DIN, will specify the acceptance criterion for the particular material. Now, these tests are carried out at ambient temperature, and that is because the ASTM records the acceptance criterion at ambient temperatures. Some people ask for it at the low temperature, the cryogenic temperature, which is very difficult to do for two reasons. One, once you've cooled the part down, by the time you've got it in the jig, it's already come up to temperature, up to room temperature again, or close. And the second reason is there's no acceptance criterion. The acceptance criteria given in the ASTM are ambient temperature. Finally, this is the last slide, I think. Remove casing after test. Well, this isn't very well defined in API 610, so you need to specify what you want to have done. Remove the casing from what? It could mean a full or partial disassembly after test. Specify it. Well, that pretty much concludes the fun for today. I hope you found it useful. I just get to advertise the next of the short courses. The next course is on startup, commissioning, and troubleshooting of centrifugal pumps. 31st of March, that's 3 weeks today. Again, 2 sessions, one in the morning, my time for the Eastern Hemisphere, one in the afternoon, my time for you guys on the Western Hemisphere. The invitation will be published very soon. Put it in your diary. I'm leaving this meeting open for a little while to allow you to post in the Q&A box. And let me reiterate, please put your questions in the Q&A box, not in the chatter box. It's much easier for me to process. Those that I can answer, I will answer here and now, live. But those that need a fuller, more considered answer will be answered in a few days. Anything you think of later, email it to info@shortcourses.rohrpumpen.com. Our marketing team are standing by to direct your questions or suggestions to the best person to answer them. And they'll be sending you the YouTube recording and a PDF of this presentation, this slideshow. as well as the summarized Q&A from both of today's sessions, this morning's and this afternoon's. If you need a certificate of completion for this course, again, info@shortcourses.ruhrpumpen.com. And here, right at the end of the presentation, are the 8 slides about Ruhrpumpen that I mentioned at the beginning of the session and didn't show you earlier, and I'm not going to show you now. They'll be in the PDF copy of the presentation you get, so you can peruse them at your leisure. Now, on with the Q&A. Let's have a look and see what we have. Sheldon Solomon says, do you recommend that the purchaser clarify critical areas during bid clarification? Yes, I would. I would certainly suggest that, and certainly at the post-award meeting, the pre-inspection meeting, you absolutely must have it clarified by then. Jorge Granado says, for dynamic balancing, apply ISO 1940 or shall ISO 21940? What are the differences? 21940 is the updated version of 1940. It's the current version. Anand Ramdas, do pump manufacturers provide 4-quadrant characteristic pump curves? Additionally, how are these curves developed via testing, calculations, or modeling? No, we don't. 4-quadrant characteristic pump curves are a very specialist field. You need to be talking to Simon Bradfield about about those. Wahid Gadamyari, can you please elaborate on hydrostatic test requirement on seal gland plate? Yes, I think the seal gland plate is part of the mechanical seal and it will be hydro tested at the mechanical seal supplier. When we carry out a hydro test of the pump, there will be a blanking plate put across where that seal flange plate would be. So we're testing just the hydro testing, just the pump casing and cover bolted together. The seal flange will be tested at the seal vendor. Anonymous attendee says, does API define the qualification of NDE personnel? Example, ANSI level 3 versus level 2 certified personnel to perform the non-destructive. I'm not sure where it is actually defined, but you most certainly do need to have qualified personnel. And when we provide our procedures, we would normally attach the records of the operators that are qualified to do those. Pump Sense Limited say, hello sir, what will be the noise limits and how far from pump set to measure? The vibration limit for API 610 pumps. Should I seal test after performance testing? Okay, the noise limit, we cannot test to a noise limit anyway. As I mentioned, you'll get indicative figures, which, I mean, the typical requirement from many people is that the pump gives less than 85 dBA at 1 meter. We can test like that, and the figures that we get are likely to be, on a big pump, are likely to be more than 85 dBA. But once the pump is installed at site and properly installed and properly tested, it will probably be, it'll be less than the 85 dBA. Should I seal test after performance testing? Well, the performance test has a mechanical seal test. The mechanical seal is fitted when you do the performance test, so you've got a functional test of the mechanical seal anyway. Raghupathy Singaraj says, if impact test is specified for low temperature services per API 6.12.4.3, what components are to be tested? That's for you to decide and specify. You might want it just to be pressure boundary parts. You might want other parts to be tested as well. I would think just pressure boundary normally. David Fairhead says, for smaller pumps, do you typically package everything on the base plate in your pump facility? If so, would this make the complete unit test easier to carry out? For example, you can install the skid on the test stand. Well, we do always assemble the complete pump and motor and seal flush piping on the stand. It would frequently then be removed again. Once we've checked that it fits and we've installed the piping, it would then be removed and separately packaged for shipment to site. It's usual to install the base plate first at site and then install the motor and auxiliary stuff. You've got to grout the base plate down at site. So it's going to have to be disassembled in any case. And as I said, most pump vendors will have very limited space on their test loops for OH2 and BB2 pumps, BB3 pumps. They'll have very limited space to be able to carry out complete unit tests and to be able to connect it up to the suction and discharge piping. That's going to be the rate determining step. And if it will take a week, and that's a week during which that test stand cannot be used. So you're going to be charged quite a bit of money for a complete unit test. Antonio Zapata, are you able to test with a crane type 2800 mechanical seal, or will a test seal have to be employed? I believe we can test with the 2800 seal. We'd need a gas system to pressurize it. But yes. Jack Pang says, hi Simon, it's very helpful. Just one quick question. For impact test criteria, do you have the ASME number on the top of your head? It's the ASME of the particular material that you're testing. There is, sorry, it's the ASTM number. I'm sorry, the ASTM number for each one. So the impact test criteria would be listed in the material code, the ASTM. Okay, that appears to be all the Q&A. Let me just go to the chat and see if anybody put questions in the chat. There's one from Saeed Alizera Mokhtar. Dear Simon, many times manufacturers have performed tests with the motor for test. Is it mandatory that the pump be tested with the main motor? No, there's two problems with testing with the contract motor. The first is that it might not be big enough. If you're taking a hydrocarbon pump operating with an SG of 0.7, for example, the motor is sized for 0.7 SG. So if you test it with water, with SG1, you might be overloading it. That's number one. Number two, most motors come with an abbreviated test. They don't come with a full performance test of the motor. So you don't know accurately its efficiency. And you need that to determine the efficiency of the pump. It's derived backwards from the overall power. So, that's why we tend to use calibrated shop motors rather than the job motor. Just looking through the chat now to see if there are any more. Okay, it seems that most of these questions were duplicated into the question and answer. So thank you for doing that. It saves me having to transfer them from the chat to the to this. Just back to the Q&A and see if there's anything else. Yes, a couple more. Pump Sense Limited say, can you tell me a portable hardness testing instrument for inspection? I'm not aware of one. I think you take the part and take it off to a bench test. Might be wrong. Raghupati Singaraj says, mechanical run test until oil temperature is better than 4 hours mechanical run test. What advantage? Well, no, they're effectively the same thing. Remember, the mechanical run test until the oil temperature is stable is likely to take 4 hours. If you want it 4 hours after that, it becomes 8 hours. The mechanical run test of 4 hours is independent of what the temperature of the oil is. If you ask for a mechanical run test until the oil temperature is stable, the pump vendors are going to charge you probably for a 4-hour test, and it'll be the same if you just ask for a 4-hour mechanical run test. It'll be the same price, I would imagine. Anonymous attendee here has said, I'm not clear if a string test is the same as a complete unit test. What is the difference, if any? No difference. It's two different words for the same test, complete unit test or string test. Okay, that appears, let me just look down this. Jack Pang has said, I'm afraid only some ASTM material specifications have the impact acceptance criterion. That's probably true. It's probably only applicable when it's a low temperature steel, for example, where it becomes applicable. A352, if I remember rightly, LCB, I think that's a low temperature steel, and so that would have an impact test. A216 WCB is normal steel. That's not suitable for low temperature applications, so it probably hasn't got an acceptance criterion for a hardness, for an impact test. PumpSense, can you suggest to me a portable hardness testing instrument for inspection purposes? There are many out there. You can Google it, and there are very many. I wouldn't feel competent to suggest one, but I can probably ask which ones we use in our test labs and get you an answer for that. Jack Pang says, should the seal gland be tested to maximum allowable working pressure times 1.5? Yes, it should be. Okay, well, it's 6 o'clock, which is beer o'clock for me. So I'll bring this meeting to a close now. So thank you very much for attending. I've thoroughly enjoyed presenting it and preparing for it. I've been in this industry 40 years now, and it's nice to be spending some time putting things back into the industry that I've taken out for the previous 40. So thank you very much, and see you again for the next session, which is on the 31st of March. Bye-bye. Anything you think of later, email to info@shortcourses.rawpumpen.com. That's a new email address, especially for these courses. Our marketing team will stand by and will direct your questions or suggestions to the best person to answer them. And they will send you the YouTube recording and the PDF of the presentation, as well as the summarized Q&A from both of today's sessions. And if you need a certificate of completion, again, info@shortcourses.rawpumpen.com, and they'll send you that. And here, right at the very end, are the 8 slides about raw pumpen that I mentioned at the beginning of the session and didn't show you earlier. They'll be in the PDF copy of the presentation, so you can peruse them at your leisure. So on with the Q&A. Let me have a look and see what we have. From can't be able to hear me at the beginning. Right. Cesar Gill says, many pump suppliers include in their quotation the shop tests with shop equipment, i.e. electric motors, lube oil console, mechanical seal, gearbox. but some end users request to use the job equipment in the tests. What do you think it is better, shop equipment or job equipment? From the technical viewpoint, not economical. If you're doing a performance test, you are looking to get the accurate readings for the flow and the head and the power. I would be using a shop calibrated motor for doing this. Using the job instrumentation, you will only really get it won't be as accurate, I must say. But if you, as I said when we were looking at complete unit test, if you are dealing with a multi-million piece of equipment, then yeah, I can well understand why you would want to have complete unit test carried out to check that everything works. But it's very expensive. Do you really want to do that on standard pumps? So I would push back on standard pumps and say, no, it's not economically viable to do that. And it takes a long time. It will take a string test will probably take a week to set up. Anonymous attendee, do you share the slides? Yes, as I mentioned right at the very last minute there, you will get copies of the slideshow and a link to this video. Carlos Mallow says, for which component and material do you recommend material certificate 3.2? Super duplex in seawater services? I don't recommend a 3.2 ever. Why would you want one? It just means you don't trust the foundry. So if you don't trust the foundry, I don't know. No, I don't think a 3.2 is ever worthwhile. I can't imagine why you would want to do so. If you're concerned about the possibility that the MTR is wrong, you can always use positive material identification on it. Shyam Kumar says, in the case of table 14, the design pressure is calculated based on max impeller or rated impeller. It's on basis of rated impeller diameter. Carlos Mallow says, speaking about weld repairs, do you have any guideline to define minor and major repair? I couldn't find anything in API 610. However, other APIs, 617, etc., defines clearly what is a major weld repair. I will have to give you a more definite answer on that later. I can't remember exactly what it is, but certainly it's a major weld repair if there's any leakage during hydro test. That is definitely a major repair. Other than that, I think it depends on the area, the surface area of the repair. But I'll give a written answer to that one. Joaquin Fluixer said, again, per your experience, when do we have to ask for a 3.2 certificate? Never. Carlos Mallow, do you use the same acceptance criteria for vibration and temperatures for a complete unit test as for a MRT? I assume that's the performance test you mean. Well, yeah, for vibration, yes, you'd be looking at the same vibration. Temperatures, you're testing on water, not on the process fluid. So bearing temperature, yes, you'd be looking at the same criteria. Carlos Mallow, how do you carry out the bump test? The pump connected to the piping in the shop, pump full of water. Okay, the bong test on for a bearing housing, it doesn't matter because you're just bump testing the bearing housing. The pump, I think, is disconnected from piping when you do this one. I think that's specified in API 610. And similarly, the natural resonant frequency test is done with an empty pump just on the nozzle head of the pump in the performance test loop. Carlos Mallow again, when it comes to dismantling after successful performance and running test, for which type of pumps do you recommend strip test? None of them? Only multi-stage pumps? Which scope? Only bearings? That's a good question. API 610 requires it for pumps more than 3 stages, so it's usual on those. On other pumps, some people do like to see it, in which case we would strip down, only if it's specified, we'd strip down the pump so that you can inspect the wearing surfaces particularly, and the bearing surfaces to see if there's been any touching during the performance test. Carlos Mallow again. What is the experience of real pumping with analysis of ultrasonic signals at 40 kilohertz? Which kind of instrumentation and data acquisition system do you use? That's too specialized a question for me. I'll have to see if I can get a better answer for that from our test stand people. Carlos Mallow again. After dismantling activities, do you carry out a rerun test, 1 hour at nominal point or whatever? If not, how do you assure there won't be assembly problems at site? That's exactly the point. That's why you don't strip down after a successful test. Carlos Mallow said, the last course I asked for the following. Do you have any guideline to inspect visually pump internals after the performance test? Bearings, bushings, balance drums, etc. Your answer was yes, it's usual to disassemble and inspect a pump after test, particularly close clearance areas such as wearing and throat bushings. And that would be right on a vertical pump, big vertical pump. It's a mandatory requirement for multi-stage pumps. Maybe I didn't explain myself correctly, Carlos is saying, do you have any guideline to inspect visually pump internals after test? No material transfer between static and rotating parts, definition of depth of rubbing. I couldn't find anything in API 610 related to this topic. No, I mean, you are looking for exactly that. If you're going to do an internal inspection, you'd be looking at the close clearance running components, so the wearings particularly and the bushings, and you'd be looking for any marks on those. Our own manufacturing techniques will tell us what the allowable smoothness and so forth on all those components are, what all the tolerances are. So we'll be checking against the original drawings for those parts. What is, thank you for this one, Shyam Kumar. What's the criteria for successful complete unit test? That's something that you need to define when you specify the complete unit test. What are you going to be testing? Are you going to be doing a complete flow against head, or are you just going to set it at a set running point, maybe minimum continuous flow, maybe actual point? You have to define all this in your discussions before carrying out the complete unit test. And what are the acceptance criteria? Perfectly correct. Milagros and Antunes do Maiolo, excuse me if I've pronounced that wrong, I know I have. How is the seal flush plan tested? How should it be requested as part of auxiliary tests? If you're using a plan 52 or plan 53, yeah, you need to discuss it with the manufacturer first. He needs to be able to be sure that he can fill it with the correct barrier fluid. It's got to be cleaned out again afterwards. You've got to have the correct pressure of nitrogen. It can be carried out, yeah. But do remember as well, you're testing this pump on water, not on hydrocarbons. So are you really accurately testing the seal flush plan if you do it? A normal performance test would just use probably water from a hose connected to the seal flush piping for doing the performance test. You're not actually doing a test of the seal and sealing system. Ahmed Metzner says we'd like to know if a PMI test is an optional test or not. Yep, it's an optional test. If you specify what you want to have PMI tested, then the pump vendor can analyze it and tell you how much that's going to cost you. Generally, it won't be too bad. I mean, I've seen it done during a final inspection. A third-party inspector has said, can you please test it here and here and here? So a PMI machine, ping, 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 quick and easy. Mohammed Shafiq, we've done the test for OH2 pumps, A and B, by using an orifice to meet the customer requirements. But we got different pump performances for both A and B. As per the test, the pump A is okay with good performance, but pump B had shown a hump after the minimum continuous flow point, which means the head rise to shut off is not continuously rising. So could you please tell us the best solution to have the pump with continuous head rise to shut off rising? What can we do best to achieve this? So what I'm hearing here is your pump A showed a continuously rising one and pump B showed a hump in the curve. What I would want to do retests on those, because it suggests that the two impellers have not been machined in the same way. So you do need to strip it down and have a look and see and analyze what has gone wrong. And as for making a pump that has a hump not have a pump, there's no magic wound. There's no magic wand that can be applied to that. It's the design of the pump. Sunaria Uwono, in case after test need to be trimming impeller for less than 5% diameter without retest, does the performance test curve after the first test curve, or can Rule Pump and generate the new curve based on the computerized calculation? Yeah, that's right. We would show on the test curve the original test curve, which would be a little bit high, and then we would generate on it as well the corrected test curve. Shyam Kumar, is checking of running clearances a must, even if strip test is not applicable? Well, no, because we would be doing those checks before we assembled, or during a final assembly. The measurements of the wearings, for example, the OD of one and the ID of the other, and hence establishing that the clearances are correct. That's a requirement during final assembly. Shyam Kumar, what will be the test duration of the mechanical run test, 1 to 4 hours, for oil temperature stabilization plus 4-hour running? Oil temperature stabilization can take up to 4 hours. It depends on the size of the pump. A small pump, it might be sooner. A large pump, it might take longer. Could be up to 4 hours. So therefore, that will make it an 8-hour test if you want a 4-hour run test after oil stabilization. Shyam Kumar, the NPSH test to be performed for both the A, working, and B, installed spare pumps, or only one pump? Well, generally it will be done on all the pumps, but again, you can specify that if you only want one NPSH tested, that will be fine. Perhaps if NPSH is not a critical issue, if you've got ample NPSH margin, then you might you might be prepared to waive the NPSH test on the second pump. Well, that's all that is currently in the Q&A. There's quite a lot in the chat. Let's have a look. I'm going to get a lot of chat here saying you can't hear me. Yep. Okay, here we go. One here. How is the seal flush piping tested. We got that in the Q&A as well. Are you carrying out NPSH test at rated point or covering all the points? The NPSH test is at all the points apart, so from minimum continuous flow to run out. You carry it out at all those flows, typically 6 points. What is the criteria to use efficiency correction per Karasik for hot applications such as boiler feed water pump to improve pump efficiency? Does it allow to use this, excuse me, sorry, what is the criteria to use efficiency correction for hot applications such as boiler feed water pumps to improve pump efficiency? Does it allow to use this correction as per API 610? I might need to double check that. I do need to double check that. I'm not aware. I don't think we normally use any efficiency correction. Performance test is done at 6 or 9 points as applicable. Complete unit test is done at which test point? That will be for you to determine. It might be, for example, if you're doing a complete unit test on a pump that is designed for low SG, 0.7, the motor is probably not sized for being able to do that test on water, because the complete unit test will be being done on water. So under those circumstances, you might have to agree that it will be done at, say, the minimum continuous flow. Is there any restriction to carry out rotor balancing for OH2 and VS4 pumps? Yes, you can't carry out a complete rotor balance on an OH2 and a VS4 pump. Again, it's because to do it, the balance machine requires that you support the impeller from either side of the impeller, support the rotor either side of the impeller. So the impeller's here in the middle and you're supporting it here and here. An overhung pump, an OH2 pump, is designed with a bearing here and the impeller here. Okay, so it's designed to be overhung, and balance machines won't take that. What is the allowable deviation to evaluate the performance test? What is the remedy if this test fails? Means pump consuming higher power or not generating the head as required. Yeah. If the pump fails on for any reason, you have to establish what the reason is and take the required action. It may be that it's a bad impeller, maybe a matter of trimming, maybe polishing. No, there's no easy answer. You'd have to establish do a root cause analysis, find out what was wrong, reassemble, retest. Mechanical seal used during the pump testing, is it the shop seal or a job seal? Well, 95% of the time it will be the job seal. Okay, well, that appears to be it. Let's have another quick look at the Q&A, see if there was anything else came in. John Lester dump it. Is the setting of your pump lift affecting the performance of the pump? So that would be on a vertical pump installed in a pit. Yes, you would just take into account the suction lift, when you calculated your overall head. But yes, it would be it would impact it. You do need to consider the lift from the water level in the sump up to the discharge level. Okay, well, that's everything. So thank you again for attending today. I thoroughly enjoyed preparing it and presenting it, even though I fouled up on the microphone at the beginning. I hope you found it useful. So see you on the 31st of March, I hope, for the next session. Bye-bye.